Welcome to our channel once again. In the previous video or in the previous session, we were discussed about the inorganic chemistry. Under that topic name is P block element. In the last session, under the P block elements, what are the P block elements and what are the atomic properties of that element? We are discussing. In this video, we will discuss about the chemical properties of these elements and some behavior of the elements. Okay? Shall we move on to the chemical properties? Okay? Chemical properties of P block elements. Under P block elements, we are discussed about 15th or group 15 elements. What are the 15 elements? The name of the elements are nitrogen, phosphorus, arsenic, antimony, bismuth, and another one, moscovium. It is not included. Nitrogen, phosphorus, arsenic, antimony, bismuth. In the last session also, we discussed the same thing or the atomic properties of these elements and their electronic configuration based on the atomic number. Under atomic property, there are a lot of things that we are discussing. The things or the atomic properties are electronic atomic size, under atomic radii and all that. Next, electronic configuration. Next, electronegativity and electron gain enthalpy, and also a physical property. Under the physical properties, nitrogen exists in the form of a gases, and others are mainly solids. The next is metallic property. First two elements of the 15th group element is non-metal. Next two, these are shows metalloids or behaves like some properties of these elements are metallic and some or few is non-metallic. Because of that, these are metalloids. Next, bismuth shows metallic property. So these are the things we are discussing. The small things of the chemical properties also discussed. The small thing of the chemical properties, oxidation state. Oxidation state. Oxidation state of these elements. According to the electronic configuration, the common electronic configuration of these elements is Ns2, Np3. This is the common electronic configuration of these elements, Ns2, Np3. In this case, it clears that there is a possibility of removal of these 5 electrons because these 5 electrons are present outermost orbital. Next, there is a possibility of removal of 3 electrons present in the p orbital because of these 2 electrons present inner side of the p. Because of that, it shows inert pair effect, inert stability, pair, these 2 pair of electron present in the s orbital. the pair of electrons present in the s orbital get stabilized because of fully filled s. Because of that, there is a possibility of removal of 3 electron. Therefore, +5 +3 possible oxidation state, as well as another oxidation state P has 3 electron. If we add 3 electron to these elements, then it gets -3 oxidation state also. Therefore, the common oxidation state of these elements is -3 +3 and +5. These 3 are the common oxidation states of 15th group elements, and this behaves differently when you move down the group. Okay, what happens? -3 oxidation state is more stable in case of nitrogen. Okay, in case of nitrogen, -3 is stable. Next, phosphorus also little bit it shows -3. Phosphorus, arsenic, antimony, bismuth. Possible oxidation state or the stability of -3 oxidation state go down the group is decreases. Slightly decreases. Nitrogen behaves -3. Next is +3. What happened in case of +3 oxidation state in these elements? +3 oxidation state, or when we move down the group, atomic size increases, correct? Atomic size increases. When we move down the group, atomic size increases. Due to that, ionization enthalpy decreases, as well as this p orbital goes away from the nuclei, correct, compared to s present inside. It attracts strongly in these elements, or when we move down the road, atomic sizes increases. Due to that, removal of 3 electron is very easy, and the 2s electrons are undergo inert pair effect. Due to that, +3 oxidation state move down the group increases. Very important point. +3 oxidation state move down the group increases, but bismuth shows 5 +5 also. In this case, +3 is stable. Although bismuth shows +5 in few cases, it is due to the incoming electron or incoming element. If more electronegative elements like fluorine comes bind with the fluorine, then there is a possibility of showing +5. Very easy. Okay, this thing is very easy. If you know the electronegativity and the nature of the incoming element, what happened in this case? +3 is more stable, although bismuth shows +5 because the incoming element is fluorine. It is highly electronegative. The meaning of electronegativity is attract strongly the shared pair of electron. Shared pair of electron get attracted strongly. Fluorine takes the electron. First it takes 3 electron, and it takes when it takes 3 electron +3, and also it has capacity to take these 2 electron also. Because of that, inert pair effect goes down. The electronegativity dominates the inert pair effect. Because of that, it shows +5. Bismuth shows +5. When more electronegative element comes, bind with this one. Okay. This is the plus 3 oxidation state behavior. Next is plus 5. Plus 5 the carbon group increases. Nitrogen does not show because the valency is maximum 4. And bismuth in a few cases, okay, plus 5 moves down to the group, increases. Reason is increase in the size. But when the size goes bigger, this 2 electron goes inside and 3 goes to outer, and removal of 3 become very easy compared to 5. Due to inert fair effect. This one is called inert fair effect. In due to inert fair effect, plus 5 oxidation state slightly increases, again decreases. Okay, there is a yes. Therefore, plus 3 is the common oxidation state. Mainly, plus 3 is the common oxidation state. But commonly we consider these 3 is the common oxidation state. Nitrogen plus the possibility of oxidation state in nitrogen plus 1, plus 2, plus 4, minus 3, plus 1, plus 2, plus 3, plus 4, plus 5. Phosphorus also in few cases shows plus 1 and 4. Okay, in few cases it shows 2 oxidation state, other 2 oxidation state, but other all shows these 3 common oxidation state. And also, due to the multiple oxidation state of nitrogen, the acidic nitrogen behaves, or in acidic media, nitrogen behaves or shows disproportionate oxidation state or the redox reaction. You are well known about the disproportionate oxidation reaction or redox reaction. In case of redox reaction, simultaneous reduction and oxidations happen. During that condition, it's the same element after chemical reaction shows oxidation and reduction in the same reaction. So then it is known as disproportionate redox reaction. And consider one example for this case. Nitrous acid HNO2 when undergo dissociation or it undergo the chemical reaction forms HNO3 in water and also nitrogen monoxide. There's 3 hydrogen, because of that I am consider 3. Okay, hydrogen get balanced 3. Next nitrogen 3 nitrogen 1 2. Then because of that is 2 become N2 plus 1 3 into 2. So it become 6 3 4 5 6. Okay, get balanced. Reaction get balanced. Clearly observe. Please note it down. What happens in this reaction? In early case, oxidation state of nitrogen. How to identify the oxidation state? By knowing the oxidation state of other element present in the molecule. 2 into 2 minus 2 minus 4, it is plus 3, sorry, plus 1, and minus 4 plus 1 is equal to 0 plus x at. So because of that it become x is equal to plus 3. Plus 3 oxidation state is observed. Plus 3 oxidation state observed in nitrous acid. Oxidation state of nitrous acid is nitrogen in the nitrous acid is plus 3. Next, nitrogen in nitric acid. It is nitric acid nitrous. Oxidation state of nitrogen, it is already known. You are already studying in the first year. 3 into 2, 6 plus 1, therefore it is plus 5. Oxidation state of nitrogen is plus 5. In this case, nitrogen monoxide, the oxidation state of nitrogen in nitrogen monoxide is minus 2, that means it is plus 2. Plus 2 oxidation state. In this reaction, there is a possibility of +2, +5, +3. Yes, it shows multiple oxidation state. Due to that, this reaction happens. Correct? So, clearly observe the nitrogen before the reaction which has +3 oxidation state. After reaction, it increases its oxidation state to +5 and also decreases to oxidation state +2. This reaction is example for reduction. Reduction of nitrous acid gives nitrogen monoxide. Simultaneously through oxidation gives or shows +5 oxidation state. Hence, this reaction is example for disproportionate reaction. What happened in this reaction? Simultaneous oxidation and reductions happen. Because of that, it is example for disproportionate reaction, and we observe the difference in the oxidation stage. This reaction is possible. Why I am considering this reaction? Because of the multiple oxidation state of this 15th group element shows disproportionate reaction. Okay. In your competitive exam, there is a possibility of asking this type of question by giving the example of this reaction. This reaction is example for disproportionate oxidation reaction, oxidation reduction. Disproportionate redox reaction. It is not redox reaction, it is simple redox reaction. So there is a possibility of asking a question based on this type of reactions. Okay. Next we move on to the other chemical properties of 15th group or group 15 elements. The second is reaction towards hydrogen. Reaction towards hydrogen. Is it 15 group elements react with hydrogen? Yes. Again, it is based on the oxidation state. What is the oxidation state of hydrogen? Commonly, it shows +1. Correct? Because of that, there is a possibility of formation of the compound with hydrogen. Why? Because it shows -3. The common oxidation state of the 15th group element is -3. Because of that, there is a possibility of react with the +5, +3, +1, +2 oxidation state elements. Hydrogen shows +1. Therefore, how many hydrogen required to make it stable compound? It becomes -3. When 15th group element goes -3, it is stable. When incoming electron shows +1, that means it requires 3 elements. 3 hydrogen is required. When 3 hydrogen is react with the 15th group elements, it forms a hydride. It is known as hydrides of 15th group elements. Okay, it is known as hydrides of 15th group elements. When it is react with hydrogen, it forms in the form of, I am consider this one. 15th group element is XH3 form. Okay, these are known as hydrides. Hydrides of 15th group elements. We consider different example. When nitrogen react with hydrogen, it forms ammonia, NH3. When phosphorus react with hydrogen, it forms phosphine. Okay, this one is known as ammonia. This one is known as phosphine. Please remember the name of the compound. Next, when arsenic react with hydrogen, arsenic hydride, antimony hydride, bismuth hydride. Clearly observe these compounds. What happened? The stability of the hydride in this case. You can consider the there is a possibility to explain the stability also by considering the stability of oxidation stage. What I am going to explain is, you can consider the oxidation, or if you know the oxidation state and the variation of oxidation state throughout the group or down the group or along the period, then there is easy to explain the stability of the compound that are formed. In this case, these are from the hydrides. We know that minus the oxidation state is move down the group means decreases. Whenever these compounds forms hydride with hydrogen, always these all elements shows minus 3, correct? Minus the oxidation state. When these shows minus the oxidation state, minus 3, minus 3, minus 3, minus 3, minus the oxidation state move down the group is decreases. Bismuth does not shows minus 3. Bismuth does not shows minus 3. That means the bismuth hydride compound is not exist. Very simple. Okay. Bismuth hydride compound is not exist because of their instability. It is not stable compound because minus the oxidation state is not stable. Or by considering the atomic size also, we can easily explain the concept. How to explain the high stability of this hydride by considering the atomic size. What happens? Atomic size when we move down the group. When we move down the group, atomic size decreases. Correct? Atomic size increases. When atomic size increases, attachment of hydrogen to the element decreases. Attraction power decreases. The attraction power decreases and taking the electron, so gaining the electron also become difficult. Okay, very easiest concept. Nitrogen, smaller size. Okay, nitrogen is smaller size. When hydrogen comes near to the nitrogen, the nuclei of nitrogen is more electronegative. Correct? Because of more electronegative, take the electron easily. The force of attraction is strong, strongly attracted. Okay, strong attraction is observed. But what happens when we move down the group? When we move down the group, size is increases. The attraction power decreases. Because of that, formation of the hydride compound decreases. It is known as, or this concept is explained by considering the bond dissociation enthalpy. Bond dissociation enthalpy, BDE. What is bond dissociation enthalpy? Energy, minimum energy required to dissociate the bond. In case of the nitrogen hydride, bond dissociation enthalpy is very high because of the force of attraction. Strongly attracted by hydrogen. This one, weakly attracted because of the small energy is enough to break down the bond between the hydrogen and the 15 group elements. So, the bond bismuth hydride is unstable and is not exist. Please remember the concept. Okay. Just I am giving the order. Okay, very important for a competitive exam. Order of stability of what? Stability of hydrides. Order of stability of the hydride is nitrogen hydride is. Next is phosphine, ammonia, phosphine. Next arsenic hydride. Next antimony. Next bismuth. Bismuth hydride does not exist. Very work. Okay, this is the stability. Highly stable. The next stability decreases. Next, what happens with acidity? Order of acidity of these elements. Order of acidity or basicity. Okay, basities are completely opposite to the acidity. What do you mean by acidity? Or can you explain the acidic nature of that compound? In your first year, you have learned the complete acidity and basicity under equilibrium topic. According to the Arrhenius theory, any elements which dissociate the hydrogen is acid. Correct? Any compound dissociate the hydrogen in its solution. Or H plus. H plus ion, dissociation of H plus ion. What it means? When easily hydrogen is dissociated from any compound, that compound is strong acid. Okay. Then what happens in this case? The compound is stable, hence ammonia does not rise to this hydrogen easily. That means the tendency of dissociation of hydrogen is less. Because of that, less acidic. Phosphine, phosphorus size increases. Hydrogen phosphorus bond decreases. Bond dissociation energy is less. Tendency of giving the hydrogen is more compared to ammonia. Because of that, acidity increases. Due to increase in the size, dissociation of hydrogen becomes easy and simultaneously acidity increases. When we move down the group, acidity increases. That means basicity is ammonia from base. You know the concept. Ammonia is base. Ammonia is base because of that stability. Okay. Consider acidity. Acidity is reverse of this one. Bismuth hydride is strong acid compared to antimony hydride. Next, arsenic hydride. Next, phosphine. Next, but what happened basically as neither as that of this one. Okay. Basicity order is basicity, acidity, stability, okay, of this compound. Bond dissociation is that also. Okay, let us move on to the next chemical property. So this is the chemical properties of hydrides of the 15 group elements. Next property is reaction towards oxygen. Reaction towards oxygen. Again, I am giving to the guessing for this case to you. What happens when oxygen is made to react with 15 group elements or 15 elements? Oxidation state of 15 group elements is +3. What is the oxidation state of oxygen now? Oxidation state of common oxidation state of oxygen is -2. Oxidation state of oxygen is -2. Therefore, the combined element should show +2. +2 is not possible in all these elements. Which one is possible? +3 and +5 is possible. When it becomes +3, and you should multiply 3 in this side and 2 in this side, this is the one compound. Oxides of the compound is H2O3 form. Otherwise, oxygen shows -2. X possibility is 5. Therefore, you should multiply 2 in this side and 5 in this side and get into another compound. These are the two possible compounds of oxides. How 15 group elements form oxide? In the form of X2O3 and X2O5. Sorry, 3 into 2. It shows. Yes, correct. Okay, X2. I'm considering a few examples of oxides. Phosphorus, arsen. Again, +3 oxidation state is what happened in case of +3 oxidation state. In this case, it behaves +3. In this case, it behaves 5. What happened +3 oxidation state when we move down the group? When we move down the group, +5 oxidation state is +3 oxidation state is increases. Because of that, nitrogen does not show this type of compound. Less possibility shows, but less. There is a one oxide. Okay, nitrogen trioxide, nitrogen pentoxides. Yes, it is exists, but stability is less. Next, phosphorus stability increases, plus the oxidation state is moved down the group increases. Because of that, oxide stability move down the group is increases. Stability move down the group increases. Okay, this is a very important concept. Now you can able to give the order, correct? Oxides of this one is less stable. When we move down the group increases. Okay. Next we move on to the reactivity towards halogen. Reactivity towards halogen. What happens when 15 group elements are react with halogen? 15 group elements react with halogen X again. Now you consider different one. Okay. 15 group element is considered as MX3 and MX5. There are two possibility oxidation state. Okay. Y plus 3 possible. Always halogen shows -1, X -1. Because of that, this one shows +3. +1 means +1 is not possible. +3 possible. Therefore, 3 halogen is attached. +5 is possible. Therefore, 5 halogen is attached. Therefore, the common representation of halogens of these 15 group element is MX3 and MX5. Example is nitrogen does not show +5. Also, nitrogen itself is more electronegative. Therefore, does not shows MX5 type of the halides. The phosphorus it can show. These type of compound, for example, PCl3 and PCl5. These are the two examples. Phosphorus trichloride and phosphorus pentachlorides. Okay. These part is not much important. Okay, for your exam point of view, you should know about these halogen compounds. Okay, PCl or MX3 type and MX5. Example is phosphorus trichloride, phosphorus trichromide, phosphorus pentachloride, phosphorus pentabromide, and arsenic chlorides, trichloride, antimony trichloride, up to bismuth. Bismuth shows also +5 oxidation state with halogen, phosphorus, with phosphorus, bismuth phosphide, pentaphosphide. Sorry, yes. This one is the possible compound. And ViF3 is also possible. Okay. So these are the compound form of the halogen. Next, reaction towards metal. Reaction towards metal. How it react with metals? Give example for metals. The S block element is mainly shows metallic property. In case of the metallic property or S block elements like calcium phosphate. Okay, what is the possible oxidation state? It is -3 possible oxidation state. Because of the minus oxidation state, it reacts with metal easily. When it shows -3, it always +2. To balancing this compound, Ca3P2 calcium phosphide, sodium phosphide, arsenic, sodium arsenide, okay, nitrogen phosphide, calcium nitrate, okay, calcium nitrate. Such type of the compound is possible with metal. Okay, these are the chemical properties of 15 group elements. What are the chemical property? Reaction towards hydrogen, extreme. First element of the periodic table, oxygen, it is electronegative elements. Halogen, the more electronegative element present in the periodic table or extreme right side of the periodic table, react to metal extreme left side of the periodic table. So react with almost all elements in the periodic table is group 15th elements. Okay, next we move on to the anomalous behavior of the nitrogen. Very important concept for your exam. The last part of this chemical behavior, there is one important thing, is anomalous behavior. Why nitrogen behaves differently? What is the meaning of anomalous behavior? Anomalous means property of the element differ from the other element present in the group. In case of the group 15th element, nitrogen itself behaves differently compared to the element present in the same group. Why nitrogen behaves differently? The nitrogen behaves differently because of the three reasons. One is smaller size of the nitrogen, small size. Reason, okay. Reason of anomalous behavior is smaller size. Next is more electronegative. Next one is high ionization enthalpy. Okay. So these three reasons for the anomalous behavior of the nitrogen. Because of these three reasons, and it is because of high ionization enthalpy, small size, because of the absence of d orbital. Okay. Absence of d orbital in the nitrogen. Because of this reason, nitrogen behaves differently. It is known as anomalous behavior. There are 5 important anomalous behavior. There are 10. I am considering only 5. What are the anomalous behavior? I am considering only important anomalous behavior. One is nitrogen is gas, while others are solids. Okay. Nitrogen exists in the form of a gas or gaseous state, other exists in the solid state. It is because of the smaller size and because of the absence of d orbital. Nitrogen does not shows any polyatomicity. Nitrogen is diatomic, but whereas others shows polyatomicity. Others are polyatomic. Others show polyatomicity. Okay. The next one is nitrogen can form triple bond with another nitrogen atom, but other form single bond. It is due to the smaller size and more electronegative nature. Nitrogen form a strong bond between these two and it forms a triple bond. It is possible in case of nitrogen p-pi bond is observed, but in other cases we can observe the p-pi bonds as well as d-pi bonds. In other cases p-pi bonds are observed. In case of nitrogen p-pi bonds are observed. Next, the hydrides of nitrogen is known as ammonia shows hydrogen bond. Hydrogen bond is observed in case of ammonia, but in case of phosphine we can't observe hydrogen bond. Okay, and the next is in case of a nitrogen or the compounds of the hydrides of the nitrogens exist in liquid state, others are gaseous state. Okay, this is because of the smaller size and more electronegative nature of the nitrogen. So these are the very important concept of anomalous behavior. Please remember any three anomalous behavior. That much is enough for your exam. There are 10 or 9 important anomalous behaviors are there, but these three are much important. Okay, therefore I am explaining this in order I will give this in your notes. Okay. In this class we discussed about the chemical property. In the next video we will discuss about the compounds of the 15 group elements starting from nitrogen. Thank you for watching.